welcome to Tech presented by Kaizen, where we will explore common cleaning questions and answers. This session has been pre-recorded and will include additional FAQs related to this specific topic at the end of the presentation. We hope it is 15 minutes well spent. Let's get started. I would like to introduce Kaizen's own Jody Saultz.
Thanks, William. Thanks for joining today's Tech to Deck. Okay, so today we're going to talk a little bit about finding the right balance with your cleaning chemistries, getting it right, the first time, and also a little bit about total balance in your whole process. So many times, I think CMs or manufacturers they often focus on one thing, but they don't focus on their whole process. So, really, the first thing that you want to do when you're deciding what you're going to do in your cleaning process, decide what you're actually cleaning. Whether it's those solvent soluble organics like oils, greases, and rosins, those water soluble pullers, inorganics like salts and flux activators, and even particulates. These are insoluble, but there is still residues that in some cases can be present on the PCB. These can be chips, dirt, um, dust, and even dead skin in some cases. So really, there's four process variables that you want to focus on. Time being one of those, belt speed, impingement time, and dwell time, and then of course energy, mechanical energy at the board level. What is that machine producing as far as flow rates and psi? Um, and then also solvency. What chemistry, what concentration are you going to run at? Are you going to run high concentration, low concentration, and then of course temperature is also a big factor in these four process variables. Some chemistries react different at different temperatures. So you may have to run higher for some applications, and of course, you may get to run lower temperature in other applications. So we've really talked about balanced chemistry in the past, in some of the past tech to techs, but if you look at the pH scale, of course, neutral being in the middle, 7. If you really want to look at the most fluxes, they're going to lay between 2 and 4 on the acidic side, and then alkalining cleaners, they're up there around the 11 to 14 range. These were very popular back in the day, but they wasn't very good for compatibility. The baths didn't last very long as well either. And then, of course, the balanced chemistries. These are going to lie between the 9 and 10.5 to 11 range, which gives you the balanced cleaning agent. So the balanced cleaning agent, it has a aqueous package, which is there for dissolving these polar soils, and then a solvency package for solubilizing these non-polar soils. Um, Functional additives, including, there's defoamers in this uh, balanced cleaning agent. There's buffers to help stabilize pH. There's corrosion inhibition. These balanced cleaning agents lower surface tension, and they're also going to give you some improved bath life and loading over the period of the life of the bath. So well-balanced cleaning agents, they need to be able to remove these residues. They need to be compatible with all these materials present. Um, Manufacturers' product and boards have changed drastically over the years, so that's very important for compatibility. And they also need to be able to remove those ionic contaminations. And they need to be matched with a piece of equipment that's right for you, the customer. Um, Usable for weeks or months. You don't want to put chemistry in a machine and have to change it out every week. And then, of course, I think one of the most important is they need to be environmentally safe, and then yet cost effective as well. So, what happens when flux starts loading up a bath that's being cleaned with a pH neutral chemistry? Well, if you look at the scale, you can definitely see if pH starts at 7.5, um, it drastically drops off quick, even at 1%, 2% versus a mild alkaline balanced chemistry. You can see the upper side of the graph between 9 and 10.5. Those are basically holding that pH range throughout the bath life. Um, so it doesn't, fall off into the acidic side as fast as a pH neutral chemistry. Those pH neutral chemistries tend to foam a lot quicker toward the end of the life of their bath, or even through what I would say is halfway through what a good bath should be. And then you could also run into compatibility issues as well as pour rinsing with these pH neutral chemistries. So really, as customers, you really need to choose whether you're going to run an inline or a batch machine, and it really doesn't matter. A balanced chemistry is pretty much beneficial for either one of these. But at the end of the day, you know, do you need a batch machine for running 300 boards a day, or do you need a small inline for running 300 boards a day? You definitely don't need a 30-foot inline, if you're going to run small runs and batch type production. But these cleaning agents are designed to run in both batch and inline um, machines as well. So um, pick your poison. Another important thing I think that a lot of manufacturers overlook is what's being actually fed to the machine. Whether it's RO or DI water, um, it's very important to be able to give that facility feed that's going to the machine the right water so you can um, basically have the clean water to um, fill the machines in the first place and then basically distribute good DI water for that last rinse before you go into the drying sections. And then, of course, another important part is the exhaust system of the machine. These are critical pieces. You do you meet minimum CFM draws, and do you also meet CFM at each port? Whether it's a batch machine or a inline machine, some type of exhaust may be required, especially on the inline machines. Some of the batch machines don't always require exhaust, but definitely inlines do. And then setup, it's always important to slope those exhaust systems toward the load end so you don't get any backflow of fluid that's going to maybe drip into your rinse section and or your dryer section for give you some cross contamination. That'll just do nothing but cause headaches later. Um, and then we always do recommend that variable speed drives be put on these machines, and then an independent blower is always recommended. Sometimes, customers will basically hook up reflow ovens and printers and all kinds of different machines to one exhaust system. And this does nothing but cause trouble because it's not a constant flow of exhaust to the equipment. So, qualified manufacturing process for cleanliness. This definition comes from J Standard 001, soldering and or cleaning process that results in acceptable levels of flux and other residues. Determination shall be made on production hardware. Rework needs to also be included in the process qualification. And of course, objective evidence shall be developed, whether it's SIR, like this magnetics piece of equipment on the side. Um, you need to be able to verify, monitor, and control that process from start to finish. And achieving cleaning stability in production. Developing and process parameters that provide the same level of cleanliness from day 30, 60, and 90 at day one. Understanding, flux load on concentration, cleaning shouldn't decrease or go away after a few days. You should get that same cleanability, 30, 60, 90 days or even longer down the road. And then, of course, understanding flux load and compatibility. Compatibility should not change after, 1 week. If you're using a well balanced chemistry, um, that's going to hold its pH, you're going to get good cleanability over the life of the bath. And then, of course, understanding rinsing. Surface tension shouldn't decrease over the life of the bath. Um, you shouldn't get any flux buildup or goo per se in the rinse section of this machine. If you do, you're probably dragging out too much chemistry. You have some exhaust issues in the machine itself. And then final product stability. The test coupons, these should represent a range from what you're going to clean today, as well as what the expectations are that maybe you're going to clean down the road. So make sure that when you're doing this testing, that you look out there um, and try to figure out the parameters that you need to be set or designed for validation for today and maybe even 6 months or a year down the road. So some of these common challenges, you're going to have entrapment under these fine pitch components. and it's important to get these flux residues or other ionic contaminants out of there. In some cases, there could be cleaning agent um, that's stuck underneath there. You could have longer wash times, material incompatibilities, and then, of course, bath life, which we think is really important. It needs to last very long, if possible. And then, um, you know, rinsing, is it ionic or is it organic? Um, these are just some of the things you really need to look at. But at the end of the day, total balance is having the right amount of, not too much, not too little of the quality, which leads to harmony and evenness. It is a condition in which different elements are equal to or in the correct proportions. And the reason I bring this up is because without a good piece of equipment, or without the right chemistry, or without the right facility feeds, you're going to run into some cleanability issues that are going to cause you problems down the road. So, in conclusion, just real quick, pH shift happens, when that acidic flux can't be stabilized. Why it's good to have a balanced chemistry. When acid is introduced to pH neutral chemistries, it's going to affect bath life, cleanability can be greatly reduced. pH neutral or versus a pH neutral with a mild alkaline chemistry, or that we would say would be balanced. And then pH neutral, it will act well up front, but make sure that when you're doing qualification that you're getting the same reaction out of your chemistry down the road during your production that you are during qualification. And soil loading, temperature, exposure time, all of these can affect this process. And if your cleaning agent, if it doesn't react within the wash process with the equipment, then you could have poor results at the end of the day. So a balanced chemistry would going to give you the best results. And then optimizing an inline or batch process, this is going to have a huge impact positively when you're using a balanced cleaning agent. So just real quick, some of the questions frequently asked on these topics is, how does exhaust affect the cleaning process? Well, if you really think about that exhaust, like I said, you want to make sure that you have the right amount of exhaust flow, and you have stacks on each one of the ports coming to your piece of equipment, so you can basically optimize that to keep everything separated. You don't want any of those exhaust fumes from your wash section going down through your machine and recontaminating your rinse or your dryer section. How long does a bath last in a cleaning process? Everyone's different. If you're running 24/7, hour wise, it's going to last the same. But if you're looking at weeks or months, it's not gonna compare to those guys that are running, 5 or 6, 10, 100 boards a day. But the best way to determine this is to do some NVR testing, and you can basically determine how life or what kind of life you're going to get out of your bath. Um, Question 3: what's an acceptable level of DI water supplied to a piece of equipment? Typically, an inline machine is going to require 3 to 5 gallons a minute, and it is cleanable down to 2 megohm of water. So don't be afraid if you're getting around 4, 5, 6 to keep rinsing. You're still okay. And then what's the biggest mistake in qualifying a process? I think just repeatability and ensuring that you do all your notes up front, go over them, make sure that what you're cleaning today is what you're going to be cleaning 3 months from now, and you get the same result. And that is achievable with a good balanced cleaning agent. And then, of course, last question: what is typical concentration percentage of a balanced cleaning chemistry? Typically, I would say that you're going to be between 10 and 15%. And with that, I'm going to hand it back over to William. And thanks again for joining.
Thanks, Jody. And thank you all for watching this Tech to Tech session. If you'd like to discuss this topic further or have any questions not answered in the session, please contact your local Kaizen regional manager or send an email to tech@kaizen.com, and we will have someone follow up with you as soon as possible. Do you want to have exclusive access to future content sent directly to your inbox, or do you know someone who would benefit from these sessions? If the answer is yes, just go to tech2tech.kaizen.com, fill out the subscription form. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.